Thanks everybody for joining us today. So today we have our presenter, Dr. Sayani Gupta, for building a new geom in ggplot2 using her own package. So before we started, I wanted to acknowledge the traditional owners of the custodian of the land of which we are. I'm on the land of Wurruri of the Kulin Nation and invite everyone to reflect on the owners of their land. I pay my respects to their elders, past, present, and emerging, and embrace their continued connection to this place. I pay my respects to all other Aboriginal and Torres Strait Islanders who may be joining us today. This will be and always will be the Aboriginal land. Also, so R-Ladies Melbourne are hosting our AGM for this year coming up soon. So keep an eye out on our Twitter account and join us if you can. And if you wanted to join our committee, at AGM will be a good time for you to introduce yourself to everybody. And there are some motivations. You can get experience organizing events, public speaking and leadership practice, bring your ideas to support and keep our community awesome. Get to know people by being part of a diverse and inclusive community with people from academics and industry, and exposure and networking. And then we're in person already, yay. So if you'd like to give a seminar or a workshop or a small talk, or want to share your ideas and your experience are, feel free to contact us via those channels. We're on Twitter, GitHub, Meetup, everywhere. So before I introduce you guys to our presenter, I also wanted to thank our sponsor, Eliza. Thank you very much for providing us this nice venue and helping us set up the event. All right, so here our presenter, Dr. Sayani Gupta, and she will talk us through with building new geom in ggplot2. Dr. Sayani Gupta is a statistician who recently completed her PhD from the Department of Econometrics and Business Stats at Monash. Congrats. So her research is on data visualization and analysis of probability distributions of large temporal data. Her research interests are data visualization, computational statistics, time series analysis, and forecasting. She's interested in connecting various large business problems to different exploratory data analysis and statistical modeling opportunities, and almost always use R to do that. So let's welcome her.
Okay, I'll get my slides up. So I hope you can hear me okay.
I thought it was a little bit. Can you try to refresh?
Can you try to maybe go turn it on and off? Okay. All right, let's see.
It won't be on the recording, so don't worry.
Yeah, this is more.
Thank you. Yeah. Okay, first of all, thank you, Dai, for the invitation as well as introducing me. Little bit about me, most of which Dai has already said, so I'm not gonna go again into it. But I'm a part of the NUMBAT group at Monash University, a team that holds fortnightly seminars on data visualization, data analysis, time series analysis. Yeah, I got to know like a lot of amazing people from there, and really lucky to be a part of that group. And thanks R-Ladies Melbourne as well, because yeah, I think the inclusion and encouragement that you guys represent are amazing, and I'm really happy to be a part of this today. All right. So I am assuming that most of the people who are here today have used ggplot2 at some points in their life and have not stopped using it if they have not moved to Python, that is. But yeah, so this is like has become the de facto visualization tool in R because it is based on the layered grammar of graphics. It gives us extensive flexibility for customizing the plots as well, and as well as adding different graphical elements. So there's different elements to ggplot. And extension along all these elements are possible that are listed here. The easiest one being the theme. So if you want to change how your panel background is looking, you want to change the color or the grids, then you can write a very simple function in order to extend themes. And then there are other elements. So I am assuming that we know how to put each of these elements while we are specifying a ggplot2 object. But what we might not know is how this specification gets converted to a plot. So ggplot2, you have to specify your data, aesthetics, and then you can add layers. So you can add a geom point, geom smooth, and facet. But how does these specification gets converted to image? So this is a knowledge that a lot of our developers also do not have. And it is a little bit important to know about it if you are working on ggplot2 extension. So I'm gonna talk a little bit about it in my slides. Yeah, so what is essentially happening here, and I have simplified things because that just makes it easier for me to understand, and I thought it would be easier for everyone to grasp it. ggplot2 is a declarative system in a way that when you are giving these instructions, it doesn't render the plot. Only when you print it, it renders the plot that we can see, which is the plot image. So what is going on in this print are these three essential functions, which is ggplot_build, ggplot_gtable, and grid.draw. So what I want to stress here is how each of these functions are related to the elements that we were specifying in the plot specification stage. So ggplot_build is basically doing all the data transformation so that can be that can actually be used for plotting the that can be finally be used by ggplot2 through ggplot_table to make some primitive graphics, which will further go to grid.draw with the grid package. So this is the workflow that's coming at the end of everything. So starting from the specification to the end of this pipeline where the specification gets converted to image, this is how it looks like. And of course, I've simplified things. So another thing that that is there is during this data transformation stage, only the stat and position are doing all the computation. In the ggplot_table, all the other elements like geoms, chord, and facet are doing the transformation. So it's just a mapping of where we started the first graphical API to the final print stage, how it is getting mapped. Now, extensions are possible across all components, but geom and stat are the most common extensions that we see generally. And today will be focused on extending these two key elements that build up the layers of ggplot. And hence we will be talking about each of these two elements in a little more detail before we move on to how to extend it. So what is a stat really? So the data that we get, or the data that we supply to ggplot2 might be a tidy data, but that is not the data we are trying to plot, right? Because if you see this box plot, what is being plotted is the quartiles, the outliers, the whiskers, and so on and so forth. And we have not specified all of that in our ggplot statement. So what stat is essentially doing is doing the statistical transformation at the back end internally, so that we don't have to provide the data transformation every time we are giving a ggplot2 statement. And basically, this is an intermediate step where stat plays a role that you can use layer underscore data to check. And there's more data that you need, or you think you will need, that layer data provides. This is because ggplot2 already provides a lot of things that that would be useful in rendering the plot as soon as possible, because even if the user do not specify those variables, it is possible for us to get a plot immediately. Yeah, so, and what is going at the back end of layer data is this function, which is ggplot underscore build, which we have talked about. So this is basically instrumental in the data transformation step that stat is bringing into.
Can I ask a question?
Yeah.
When you specify layer underscore data and you put p, so say that in the ggplot you had multiple layers, or did you just print them all? Like you can just find all the statistics for every layer.
I think you will be able to find the final statistical transformation. Yeah.
All the different
Yeah.
layers.
Okay, now going to geom. Geom is the way you would want to plot your data. So you might use base graphics like points, lines, polygons to draw your data, or some combination of these graphical elements to plot your data. And I am giving some few examples where I am displaying the distribution of the data, but in different possible ways. So the first one that you can see is a box plot, again, where we are using crossbars or rectangles, as you can say, to display the statistic that we have derived from the stat step. And here we have got quantiles. So after computing the quantiles in the stat phase, we could have plotted it through lines, or we could have used points or anything, right? So, but we have chosen lines. So that's a kind of geometry that we have chosen to display. So that's the role of geom here. So this is a question that I think could come in when you are trying to extend ggplot, especially because a lot of geoms already exist in the ggplot2 framework, and many more extensions are already existing. So why is it needed to build another one? So the first one is that there could be something very specific to your field that you might want geometry for, or any ggplot2 extensions actually. And the ggplot2 developers might not be bothered because it's not as general as you would want it to be. It's very specific to the field, and experts in the field only should be doing it. Also, suppose it is existing in the base graphics framework. You might want to bring it to the ggplot2 framework so that you get all these flexibility in terms of integrating new graphical elements and also customizing it, right? So if you want to look at ggplot2 extensions, you should look at this gallery, which is a lot of extensions. And it is highly recommended that actually you should look at them before you start building a new geom, because you might actually find something which is very similar. And then you don't have to go into the entire theory of how things work. Okay, my experience as an intermediate R user, I would say, when I started, was very difficult to connect that how the interface is relating to the underlying machinery that is making ggplot2 works. And you won't care till you are at that point where you have to actually build a geom and you have to understand what is going on behind the curtains. And it didn't help that there are not too many guides that are widely available. When I started, and that's why when I started looking at the source codes that were very long and that were like with many variables and parameters. So yeah, you can just get a little lost and frustrated and not understand how all of that fits together. But this is basically a modest attempt to point to essential ideas that you need for creating new geoms that I have understood. And since some of us have understood and we are able to build a new extension, it is definitely possible. We did it, and I think with some effort and understanding, everyone can do it. Okay, so that brings us to our package gghdr that we have developed, and it is on CRAN, and it implements highest density region plots in ggplot2. So I'll explain in a bit what is highest density region. And it is inspired from the R package hdrcde, which already was doing the computation and visualization, but in the base graphics. And hence it was not allowing the flexibility and customization that we need. So why HDR? Why was it important for us to build another geometry on top of whatever was existing? So that I'll explain through this example of where we have the eruptions and the waiting time. So duration of eruptions and waiting time from the old faithful geyser data in Yellowstone National Park. Right, so the distribution of eruptions is plotted here, and you can see that it is a bimodal distribution where the eruptions are happening either around 2 minutes or 4.5 minutes, and rarely around 3 minutes, right? So this is the kind of insight that you get when you look at the entire distribution. Now, when you're trying to summarize this distribution through a box plot, of course, you're not able to get that kind of insight, right? Whereas the HDR, which is the highest density region, that gives you these areas and also the local modes, which specify that, okay, you've got bimodal distribution, which reflects the insight that you are already getting from a density plot. So yeah, box plot were not suitable for summarizing multimodal distribution. And this is not the only benefit of highest density region, but an illustration of how it could be useful. Okay, so yeah, so Rob in his paper, Computing and Graphing Highest Density Region, have already talked about this computation and graphical representation. So what is highest density region all about? So just to have an overview of what it does, essentially, so there could be many ways to summarize a distribution in terms of probability. So you can see that if this is the area that you're considering, this also is the 75% region consisting of, a region which covers 75% probability. The second one is the same, but only the HDR here consists of a region that shows bimodality. So what's going in the background is in HDR, every point in the sample space would have more probability than any point outside the sample space. And it should also consist of the least possible volume in the sample space. So that these two ideas basically lead to the construction and the computation of HDR. So just by definition and design, the HDRs could potentially consist of several disjoint regions. So the 75% HDR, as you can see, is consisting of 2 regions here, but depending on the shape of the density, it could potentially consist of more than 2 distinct regions as well. Okay, a little bit more about gghdr before I move on to other things is other than geom box plots, there's some additional capability that gghdr has. That's in terms of showing you the bivariate. So this is the one that I'm talking about. This is showing the bivariate highest density region and coloring by the region in which the points lie. So this was existing in the base graphics package as well. But this is something that is new, that adding rug plots, HDR rug plots, which can show the marginal distribution of the variables on top of the bivariate distribution. This kind of things were not existing and were added as we developed gghdr. And also this one, that across different categories, like conditional on different categories, how the gghdr for a continuous variable vary. So if you want to know more about this package, and if you think it would be useful for your application, you can look at the CRAN page or the vignette, and all the sources are given at the end of the presentation. Okay, all right. Now, where do we start? So we have built a geom, a new geom, but when someone is starting off, where is the place that we can start? And there's a lot of ways that you can answer this question, but it's just useful to acknowledge that all of these layers like geom and point, they are also functions. So if you are just printing geom point, basically that gives you some things which essentially says that, okay, that has a geometry, that has a called geom point, that has a statistical transformation which is used by stat underscore identity and a position as well. So that is the basic structure of geom point, right? And if you try to see the geom point structure, you will be able to see that there is this is nothing but an instance of the layer, which is also consisting of several possible methods. So suppose compute aesthetics, compute position, all of these are methods which are like functions constructed for the geom point class. But there's these fundamental elements that are present, which is stat, geom, position, and so on and so forth. So basically, if I want to build a layer using ggplot2 layer and give it this structure, then you could think of it like any geom could be thought of as a function which looks like this. Some geom, some stat, and some position. So for example, for box plot, if I just extend it to box plot, it should be some geom, which is geom box plot, stat, which is stat box plot, and position. This should be the identical basic structure that you might think box plot has, but when you print geom underscore box plot, it also gives you a lot of other variables that again ggplot gives us for free, because it just is designed so that we can draw the plot with all of these inputs not being specified by the user separately. Okay, so I'll be very briefly talking about ggplot2 because whenever you are working on ggplot extensions, you have to go through this factory kind of a thing that is Thomas Peterson's, in Thomas Peterson's word, it is a factory which basically has classes, objects, methods. And from this journey from data to plot, what it does is it creates different objects. And then each of the objects goes through different methods. And that happens a lot of times before it gets converted to a plot. So you can think of this as a factory in which all of this is happening. And this is basically that's the umbrella that connects everything that that is going behind the scenes. So now let's talk about some examples, and also let's talk about when would you want to create a stat or a geom or both, right? So this is a simple example where I am I'm showing the same geometry but using different stats, right? So in the left hand side, I have got geom point but have put the stat as smooth. So what it does is it plots the conditional mean, but in the next one I just plot the raw data, right? So they are different statistics, but it's the same geometry, right? So the point here is, if the geometry is already existing and you want to have a different stats that uses this geometry, then you just have to build the stat, right, which is like the deployer calls, and that's just like the data transformation steps, and that you can put into the to be used for the existing geometry that you have. So other examples of drawing, of similar examples could be geom segment, where you draw an arrow as the input, and also and geom quiver. So both of these geometries look like it has got a segment and an arrow element to it, but they have got different statistics. Okay, another example with same stat but different geometry. So it might happen that you've got the statistical transformation in place by someone, but you want to project it in a different way, in a different geometry that's not existing. So these are the cases that you should try to build only the geom layer, because the stat layer is already existing. A simple example would be looking at the geom histogram and geom freak poly. So if I see the class of geom histogram $stat, you can see that stat bin has been used. So it is a subclass that's of stat that is being used by geom histogram, and similar for frequency poly as well. So what this does is this price has been binned into several categories, and then for each of the bins you are counting. You are just plotting the counts, right? And in this one, if you are doing geom histogram, you want to display the counts through bars, and if it is geom freak poly, you want to display the counts using lines. So only the geometry is different, but the stats used is the same, and you would want to use them for different purposes depending on what you're trying to convey. Now it might happen that you've got the stat, and then the geometry that you are trying to build is basically a combination of different existing graphical objects, and that's a lot of times that is the case where we are combining different geometrical objects to get a new geom. So for example, geom smooth, which combines geom line and geom ribbon. So when you are printing geom smooth $draw group, you will be able to see that it essentially just uses geom ribbon and geom line. Now, what if you want to build a new stat and a new geom? So that's an example of my package, gghdr. And I'm going to walk you through that and then explain how I've gotten into understanding how to extend a geom, right? So the stat functions already existed, as I told you, but it was lying in some other package. So what we had to do was call functions from HDRcde to take care of the statistical transformation and then produce it in a way, in a tidy format that can be used by geom functions. And the geom functions were new, but it was just a combination of different graphical objects that's already existing. So that is something that we have to build. Okay, so now this is the problem that you have, that you want to build a new stat and a new geom. Where should you start? So the action plan could be to get an idea of what you want to draw, and just looking at the plot and trying to see what are the primitive graphical elements that led to this. So that that helps to decide what to put in the geom layer, basically. And also, if your geom looks very similar to an existing geom, then you can start from there, in the sense that this is where I started, because box plot, the normal box plot looked very similar to HDR box plots. So I went and looked at the source code for box plot in order to understand how I should extend HDR box plot. Yeah, so the next things are a little more involved, in the sense that I will again come back to them, but you never have to like build a new ggplot2 class. You can always like subclass from the existing geom and stat ggplot2 classes that are already built inside ggplot2. So we always have to subclass from the geom or the stat in this case. And the naming convention is that if you are going to build a geom which is called geom underscore new, then the class should be called geom with capital NEW. And yeah, so start small and build up the essential components so that you can reach where you're trying to reach. Yeah, so I'll tell you how I started comparing the geom box plot and geom HDR box plot to understand what are the necessary stat and geom component that I need to finally get into my code, right? So for box plot, you've got these 5 number summary, but for the HDR plots, depending on the probability coverages that you would want to look at, and also the shape of the density, there could be different areas. So here you can see that the area is the 50% as well as the 99% probability coverage. Both are split into 2 areas, right? So area 1 and area 2. But it could be that depending on the shape of the density and the number of probabilities that you're trying to cover, it could be more than this, right? So it's a variable. But for this example, we needed all of these statistics as well as the local mode or the global mode, depending on the input. So all of these statistical transformations need to happen to the data before we can actually plot them. So this is comparing the stat. Now comparing the geom between geom box plot and geom HDR. Now look at it that in the geom box plot, what you can see is this entire box, which could be actually thought of as 2 rectangles and a median, or it could be thought of as a crossbar. And then you've got these whiskers, which are segments, which are represented by segments. So you want to draw the whiskers through a segment, and outliers through points. So these are the geometries that would somewhere appear in my geom code in box plot, right? That's the combination of graphical objects that's happening. Whereas for geom HDR box plot, what are the essential what are the ingredients? It's the segment and the rectangles, right? So in the geom HDR box plot, what you could see is a combination of segment and rectangle only. Any comments, suggestions till this point? Okay. Okay, so promise these are the like last two things before we actually dig deep into the code and try to see how we can modify or change things to get what we want. So creating new geoms in ggplot2 generally happens by inheriting from a parent geom class, as I just said, and it happens in 2 steps. So so you have to build a geom new, which is a ggproto function, which basically builds the class, the subclass from a geom, and it gives you all the attributes and the functions that are required to plot the data. And then you build a geom underscore new function, which takes this geom new class and then returns a layer that will actually be used by ggplot2 later. So since this step is happening, we are able to add on a ggplot2 interface. We are just able to add layers on a ggplot2 interface. But the real work happens here. This is like kind of a black box because after we put it in a layer, it gets very nicely delivered after we try to add elements of different geom. What happens here though is we try to set up the functions which will take the inputs from the statistical transformation and build some graphical primitives that would be finally delivered to the grid package to plot. So the most important function here is the draw underscore panel, which will do all the work. The building a new stat is similar in the sense that there's two steps to do this again. So stat new builds the class. Stat new builds the class by inheriting from the parent stat class, and then it does all the computation through the compute underscore group. So this is where all the data transformation kind of things happen. And then stat underscore new is the function which layers which outputs a layer that can be used in ggplot2 for further to be used by further geoms or ggplot2. And this is the stat that's specified here comes from this stat new class. Yeah.
So with this two, so if the Pierce one was a geom one and this is the stats one,
Yeah.
what are the output for the first function?
Yeah, so Dai's question is that we have got 2 separate steps to develop a stat or a geom. What is the output for each of these steps? Okay, so honestly, when I was trying to do it, I had looked at the because compute group is also a method, which is a function that does all the computation, right? So I've looked at each of the computations separately, but not like what each stat new or stat underscore new would give, because stat new is basically a class, right, which is being used inside stat underscore new to deliver the ggplot layer. Yeah.
actually a function. So that is specifically a class not or stat also could work.
So you are trying to say if you need to specify the attributes of this class?
Yeah.
If you specify the class, then the attributes are also coming along with it. I don't think you need to specify the class. Okay, so now we know what are the geoms, what are the statistical transformations that are needed to build the highest density region plots, and we know the basic structure of how to build a stat and how to build a geom, and the most important functions for each of them. With that knowledge, we can actually go to stat HDR and see how things work. So just if it is a basic structure, what we can do, what we can see here is, yeah, we have developed a stat HDR function, which is a ggplot2, which is making the class using ggplot2, and that is being called inside this stat underscore HDR while we are specifying the argument stat HDR. So this is exactly what we learned to do in a very general framework, right? Yeah, so there are several components to it, but the most important one being compute group, where the raw data is being converted to the transform data, which is being used later in the pipeline. So what we have done here is essentially call the HDR function from hdrcde package, which already does all of these computations that we need, all of these statistics that we wanted to have, right? But it doesn't give it in a tidy format that geom can understand. So what we have done after this is basically define a data frame which will have all of these components as different columns for being able to be used by geom. So that all of this linking part can happen in an easier way, what I've done here is I have written the code, but the extra parts, these extra parts could be very essential for having your geom to work, but that's not the part that I want to stress. I want to stress on the most essential components of building a geom, and hence I have removed parts of the code by extra so that it can be rendered in a computer in a nice way. So this is my mind map of how things work. And if there are some people who are very experienced in this, and if you think that this is not how things work, or there's something else going on, then I'm happy to listen to it. And yeah, we would let's learn together. So here, yes, so stat hdr.r is the R script in which all the stat computation is happening, and geom boxplot hdr boxplot.r is the part where all the geometry related computations are happening, right? So this I already showed that stat HDR is a class which is being called by stat underscore HDI, which is a regular function through this stat, right? And the important component of stat HDR is this part that also we were seeing in the GitHub page where we were trying to see the stat HDR functions. Yeah, and for the geom part, this is the setup stage, the structural stage where, okay, you need to build a stat underscore HDR and stat HDR, and you can just have the essential components and have the structure ready. But within this structure, we will come to what are the essential components of geometry. So in my mind, where should we go first? We should be first computing the data transformation step. After that, we should be actually thinking about this, which is what are the graphical objects that I need for showing this steps, these transformations. And as I already told you that those were geom rect and geom segment. So our final graphical object would be a combination of geom rect and geom segment. But of course, we had to give the inputs for geom rect and geom segment, right? So let's look at geom rect, which uses the input box, right? Now let's go back to box and see what it is making. Of course, box is taking the inputs from this statistical transformation stage and building the inputs that is required by geom rect, right? Because if you're using geom rect, you have to provide the inputs. You are building the inputs of geom rect using the inputs from this statistical transformation. Similarly, when you're trying to draw the mode, you will use geom segment. Geom segment has X, and Y, and color as the arguments that need to be fed so that geom segment can be drawn. And those are being made using the statistical transformation that comes from the stat hdr.r function. So this is how I consider that things kind of fit together, and this is the steps that you should follow to build a new geom. Now there's different steps like the default aesthetics, the optional aesthetics, and the setup data that you need to set up. But I feel like if you have got this part right, then most of your work is done. Happy to discuss more about it. I've got another slide where I want you to think of a similar mind map for box plot, where you would think of a similar structure, but these statistical transformation and the graphical objects that you're trying to combine would be different. And also remember that in box plot, you would have outliers, which would be represented by points. So yeah, if you want to give it a shot and think about it using this mind map, or come up with something else that you want to discuss, I am all happy to discuss. Yeah.
So in there, when I'm looking at the bottom one says geom rect and geom segment in the draw panel, and basically, like, is it the case that when you specify the mode of the panel params, they need to have specific names, like when you build your mode or your box, you need to be aware of the exact naming that this function needs, or no?
No. This could be named as box anything.
No, I mean like the name of the arguments.
Oh, the name of the arguments like x mean and yeah, that has to be, at least if you're not mentioning the arguments, it has to be in order.
Okay.
Right? Like just as ggplot2 works, like if you are not mentioning the argument's name, then it should be in order for the words.
So like you go into the geom function that already exists, you need to be aware of all the different arguments that you need.
Correct.
And then make sure that you specify them
in that order. Yeah, so I'm just being terrible with the slides at the moment. Yeah.
Yeah, okay.
So every time we come up with a new geom HDR, it has to be based on some kind of stat HDR. So
No, it can be different HDR, different stats as well, but you have to think about the geometry. If the geometry needs those statistical transformation that some other stats can provide, then you can use geom HDR in with some other stats. You just have to, yeah. So till the time you think, I will have my charge. Oh, is there one here? Oh, I don't think so.
do you want to use my laptop? I have this slice there. We can just plug mine in.
Yeah, sure. Oh, yeah, sorry. Yeah. Just wait.
Okay.
Are you unmuted there?
No, this is on. That created the entire.
Let's say if I have this kind of structure set up, and if I just dump this thing into a block and totally break down all things. Do built-in content without all this and display all of it. Like when you go to the mouse on there, we probably will add a layer of interaction to have all the labels, like all those like zooming the mouse, etc. I feel like for the stuff of that way, most of the time like those stuff like really have like fully customized function for fully customized geometry. Will probably be able to show all things correctly and automatically all the settings that
So correct me if I'm wrong. What you're trying to ask is how Plotly interacts with the internals of ggplot here?
okay.
Or finally, like after you have the geom layer, the stat layer, then I don't think it will interact with Plotly because we generally use geom pointer, geom anything, right? Geom star with Plotly and it works fine. So after this is built up and you are putting it in a package and you're calling the library, I think it should not be a problem if you're using Plotly. But if you are asking it how it interacts with the internals of it, so what is the problem that you face if you?
Well, like what I'm thinking is having this kind of fully customized widget in there.
Yeah.
Things I'm not sure whether this thing can be displayed in the correct fashion when using Plotly. But what happens, like ideally speaking, Plotly should be able to pick up whatever you have. Then add one extra layer, which is the interacting layer. But sometimes, like for the thing that I had to think, I know that sometimes if I want to have the feed layer, I didn't add a button. So sometimes probably won't be able to pick up those kind of like things. I'm just wondering when having this kind of like high level, like really high level of customization, whether Plotly can display all things in the correct fashion.
I haven't tried it myself, so not sure, but I would hope that if it is packaged well and then you're calling the library and loading it, then all the geometry elements that should be working the way it is for the ggplot package. All right. Yeah, so we can potentially go to the GitHub page where we've got the code for geom box plot, sorry, stat box plot. And try to see the compute layer here. There's lots of things here because I started with this. That's why I've put extra so that we don't get lost in the other complications. So here compute group is basically computing this 5-point summary that we would need, and then there is a df data frame which takes all these components and put them in a tidy format that could be used by the geom layer. And also I wanted to show that what is happening inside the geom underscore box plot is this draw group, where the first thing we should be looking at is what we want to draw. And if we go to the end, we will be able to see that there is some outliers group, which has been modeled through geom point, geom segment, which essentially should capture the whiskers, and geom crossbar to draw the box, right? And so again, each of the inputs for geom crossbar, geom segment, outliers, crop geom point should come from draw group segment as well, where you can see that this box has been made using the x mean x max that was calculated at the transformation stage at stat, and then they were being used to construct this box or these outliers, which were further rendered using geom segment, geom crossbar, and outliers. Okay, so the other authors of gghdr is Mitchell, who is here, Stephen, Ryo, Daria, myself, Thomas, and Emmy, who is also here. And this, this we developed during the R Open Sci in 2019 in Sydney. And if you are interested in extending ggplot, these are some resources that I found out to be really helpful, and I think it would be helpful for you also to have a start. Yeah, that's all from my side. If you don't have any questions, or if you have any questions. Thank you. Should I leave the Zoom?
Is we finished?
Yeah.
Dr. Sunny, can you provide some use case for this?
Use case? Yeah, so one of the use cases that I showed was any distribution which is which has got more than one mode, and you're trying to summarize the distribution, you would want to use highest density region. If you want to define a confidence interval, so that could be defined in several possible ways. So it could also be used in that case.
In terms of computation, I know it's using hdrcde under the hood, but if you have a big data, do you know like how effective it is, like in terms of the stat computation? Or you've only done like moderate, so you haven't really had any.
Yeah, not a very big data that we've tried with. Yeah, that's a good idea. Maybe I should try it with other big data sets to find out what's the characteristics there.
Or in bottleneck would be to join.
Yeah, so that would be like to make the stats also.
My own preference.
Yeah. Okay, so there was just like some appendix slides in order to know the functionality of gghdr more. But yeah, that's all from my end. Thank you again.
I think that's all